Hi, my name is Denise Marshall. I'm in the Data Science and Machine Learning course 6315. I currently work in IT. I've been in IT for 15 years in the oil and gas industry. And I'm going to explain my key points of this Google Colab. And I hope I do the time allowed. First, Google Colab is a cloud-based. It's a cloud-based platform provided by Google where users can write, execute, share, and comment on Python code, which I have a hard time doing coding. It is especially popular among data scientists and machine learning practitioners because of its seamless integration with deep learning libraries and free access to graphics processing units, which is GPUs. Google Colab Notebook are similar to Jupyter Notebooks and offer an interactive environment of experiment with code. Face detection refers to computer vision techniques. Okay, I'm sorry, I'm messing up. Face detection refers to computer vision techniques on identifying and locating human faces in digital image or video, like we're doing now. Unlike face recognition, which identifies who the face belongs to, two, face detection simply detects the presence of faces in an image. The technology uses cascades and features of face-like distance between your eyes or the shape of the nose for detection. That's one of the face detection. Face feature detection is kind of close to face detection, but face feature detection is a finger granularity of face detection, wherein specific features of the detected face, such as eyes, my eyebrows, nose, your lips, and chin are located. Algorithms often use edge detection and pattern recognition, work on highlighting the contours and unique patterns of each of these features. Face encoding. I found that very interesting, face encoding. Face encoding transfers the raw image of a detected face in a fixed size numerical vector representation. I can't even speak today. Representation. This encoding captures the unique characteristics of a person's face in a way that can be compared with encoding of other faces. Typically, deep learning modules, especially convolutional neural networks known as CNNs, are employed to extract these high dimensional vectors. The vectors are useful because they convert to the complex visual data of a face into a format that's easy to compare. I find that very interesting. The dlib and face underscore recognition. Dlib is an open source library in C++ that provides machine learning algorithms designed for use in the real world. It's widely used for tasks that involve object detection, facial recognition, and other such applications. Okay. Face recognition is a Python wrapper built on the top of dlib, simplifying the task of face recognition in Python. It extracts the complexity and let developers work with a more user-friendly API. I used to work with developers a lot. Face landmarks. Face landmarks are specific, predefined points on the face. For instance, it points at the corner of the eyes, the tip of the nose, the corner of the mouth, and etc. By identifying these landmarks, algorithms can gain a structured understanding of facial features and can accurately overlay the manipulated facial data. Image and quality detection accuracy. That's very important. The accuracy of face and facial feature detection can vary on image quality. Factors such as the resolution, the brightness, contrast, and noise can impact how well algorithms detect and recognize faces. Additionally, external factors like light conditions, obstructions, and the angle of the face, frontal and side view, can all influence detection rate. Now, this would be a good detection rate because I changed my head, I moved my head. My light in here is pretty bright, so it can be a good quality or poor imaging. Face comparison. Using face encodings, you can perform face comparison. This process identifies where two face encodings are similar enough to be considered as representing the same person. The underlying logic checks the distance between vectors. It is below a certain threshold. The faces are like the same. Or you can custom models. While the face recognition library provides pre-trained modules for general face related tasks, there might be scenarios where specialized data or unique requirements necessitate custom modeling training. For instance, if working with images under specific lighting conditions or with demographic not well represented in general data sets, training a custom model with representative data could yield better accuracy. Why use Google Colab? Well, number one is the zero setup required. You don't need a Google account and a browser. No special software installation is required. Another point would be free access to GPUs. Google Colab provides free GPUs access. The graphic processing using is for GPUs, which I know you know that, making it ideal for deep learning tasks. Third, there's no hardware restrictions. Since it's a cloud base, you can use it irrespective of the capabilities of your machine. Easy sharing. You can share your Colab notebooks just like with your Google Docs or your Google Sheets. You can comment on any part of the notebook. I think that's pretty cool to me. You can set up Google Colab. Well, to how to set up the Google Colab, you just access Google Colab. You open your web browser and you navigate to Google Colab. Sign in with your Google account if prompted. Then start a new notebook. You click on a notebook to start your new project. This would open a new tab with fresh notebook. Notebook interface. This interface is divided into cells where you can write and execute code. By default, a single code cell is provided, but you can add more by clicking on the plus code or the, shift text, the plus text, or on the top left, the code, plus code adds a new cell for Python code, while the plus text adds a cell for Markdown or texture content. If you want to run a cell, you just click on the play button. the triangle icon on the left side of the cell to run it. Alternatively, you press the Shift plus Enter to run the current cell and move on to the next one. Installing necessary libraries. You use the dlib and the face underscore recognition libraries. You enter line by line on Colab. For instance, you do extra explanation, PIP space install place dlab. Then on the next line, you do explanation, PIP in space install face underscore recognition. That's pretty much, setting up the Google account on the Colab. I think I have only 10 minutes. I was supposed to at least have 15 minutes. Minimal. Oh my God. Okay, face detection on the first part of the project. You type the highlighted parts in the Colab, exclude the punctuations from Google.Colab, and you import the files. This line import files module from the Google Colab library. Google Colab provides this module as a utility to interact with files. With this module, you can upload files from your local machine to the Colab environment. Also download the files from the Colab environment to your local machine. So I pretty much went over, I just did my key points. Google Colab, did face detection, face feature detection. Those are pretty close. Face encoding and the dlib and face recognition. And also key points of what face recognition is. What it is in the little brief description. Did face landmarks, image quality and detection accuracy. I went over that. Face comparison. I thought that was very interesting. It's kind of, to me, I wonder what AI, would do as it goes to face comparison. That's, pretty interesting to see how AI would be, do a comparison to AI and face recognition. It's probably pretty close. Face comparison. Then I went over a little bit of the custom modules and also explain why use Google Colab. I think, like I stated before, is zero setup required. You don't need a Google account to browse access. You don't need no special software. Installation is required, and it's free access to the graphics processing unit. GPU, making it ideal for deep learning tasks, which I like that most. And besides, there's no hardware restrictions since it's a cloud based, so you can use it irrespective of the capabilities of your machine. That's pretty cool. And lastly, easy sharing. You can share your Colab notebooks just like you would do with Google Docs or Google Sheets, or you can or Sheets. You can comment on any part of the notebook, which I found that was pretty interesting too. So this is a brief, just key points of why use Google Colab, and a brief little points, how to, set it up. You access your Colab, you start a new notebook, and your interface, notebook interface, and running the cell, and you install necessary libraries. And, I think Google Colab is pretty neat. I really enjoyed this class, and I enjoy all the assignments and also enjoyed all the going, answering, reading different students, what their thoughts are and stuff, and really interacting with the class. I found it very, very helpful. And this ends my video, which I do not like making. So